Alright guys, so this is lesson 131, day 2. Yesterday we talked about what these warm-up problems looked like, and we talked about how to simplify radicals with imaginary numbers. So that's what this is. So something like the square root of 9, negative 9. Square root of 9, remember, is 3, but since you're taking the square root of a negative, it's an imaginary. So your answer is 3i. Something like 216, I wanted to give you something of a little bit bigger number and say that if you had a calculator, how would you go about figuring out perfect squares of 216? So you take 216 and you divide by perfect squares. So don't divide by numbers like 5 or 7 or 14. We want to pick perfect squares. And I would start high and work backwards since we want to find largest perfect squares. So let's say I start with 80, let's say I start with 100. So that's 10 squared. So that doesn't work. And then I go down one. So 9 squared is 81. So that doesn't work. 8 squared is 64. So that doesn't work. 7 squared is 49. So that doesn't work. 6 squared is 36. That works. So if I rewrite this, I have negative square root, and then I'm going to write negative 36 times 6. Okay, so I'm taking the square root of negative 36, which gives me 6i. The negative is on the outside already, so that's right there. And then I'm left with radical 6. So I have negative 6i radical 6. Okay, let's say you get something like 405. So I start with 405, and again, I divide by 100, or 10 squared. Doesn't work. 405 divided by 9 squared is 81. So that works. So I rewrite this. I have negative 5 times the square root of 81 times 5. Notice that there's no negative under the radical. So the square root of 81 is 9. So that's what comes out. And 9 times negative 5 is negative 45 square root of 5. So that's my answer. Okay? So if you had bigger numbers like that, you can always divide by perfect squares. Just don't divide by anything else. Okay? Alright, so let's get this out of there. Alright, so to talk about today's stuff, what is a radical? Radical looks like this. It's just saying what times itself gives you a number. So like this, if I put a 25 under here, I'd be saying what times itself gives me 25, which is why the answer is 5. Okay? A complex number, remember we talked about yesterday, is in the form of a plus bi. That means this is your real plus your imaginary. Okay? Alright, the directions say to rewrite each complex number using a radical. So complex number means imaginary. So it's saying write each imaginary number using a radical. So that means that a radical has to be your answer. Okay, so what I'm saying is that is going to be my answer. So I'm rewriting the imaginary number to look like a radical. Well, in order to make this go under the radical, I do the opposite of what we did before. Before, to take it out, we did the square root, so now we want to square it to go back in. So 2 squared is 4, and in order to make it an imaginary 2i, I'd have to be taking the square root of a negative. So the square root of negative 4 is 2i. Okay, so let's try it again. I have 7i, so I want to put it with a radical. So in order to put 7 back under the radical, I'd have to square it, which gives me 49. But the square root of 49 is 7, so to make it imaginary, I take the square root of a negative 49. Okay, next one. I have this negative symbol that throws us off a little bit. That negative stays outside the radical. And then in order to put 6 under the radical, I'd have 36. But in order to take the square root of 36 and get an imaginary 6, I make it a negative. Okay, so the square root of negative 36 is 6i, and then when I bring it out, I would multiply it by this negative to make it negative 6i. Okay, so we're undoing what we did yesterday. Next one. If I want to put this back under the radical, just like we were doing before, I need to square it. So this 3i, if we square it, gives me 9, negative 9, and then times the 5 that's already in there. Okay, because again, if I take the square root of 9, I get 3, and because it's a negative, it's an imaginary. So I multiply these two things together, and I get the square root of negative 45. And then this is what it looked like yesterday. Okay, next one. In order to put the negative 5i back under the radical, I square 5 and I get 25, but it'd have to be taking the square root of a negative so that it's imaginary, times the square root of 10, which is already in there. So again, check your work. The square root of 25 is 5, and because I'm taking the square root of a negative, my answer was this negative has to stay on the outside. Okay, I multiply what I get left with. Negative stays on the outside. Negative 25 times 10 is negative 250. So this is my answer. Okay, and again, just like in number 3, that negative stayed on the outside. Alright, I want to do 6i, and I want to put it back under the radical. So 6 squared is 36, but in order to make it imaginary, I'd have to be taking the square root of a negative 36, and then times 11. And again, I'm going to give you more reasonable numbers than this. So you do 36 times 11, and then this is the square root of negative 396. And now notice that all my answers have radicals in them. Okay. Alright, and then this is what's leading us into our bigger scale for the day. Alright, so we talked yesterday and we said that I equals the square root of negative 1. Okay, so then what is I squared? Well, if I is the square root of negative 1, then that means I squared, we should be taking I and squaring it. So we're taking I, which is negative 1, and we're squaring it. The question is, what do we get? So here's some things to think about. Look over here. If we have the square root of 7 and we square it, so I'm going to just show you, you don't need to do this. If we take the square root of 7 and we square it, notice we get 7. If we take the square root of 31 and we square it, we get 31. If we take the square root of 846 and we square it, we get 846. So notice what's happening. When we take the square root of a number and we square it, we get back to the original number. So that means that a square root and a square undo each other. If I take the square root and then I square it, it undoes it. If I take the square root and I square it, it undoes it. So that means that when I come over here and I look back at these imaginaries, if I take the square root and I square it, it undoes it, which means that I squared is negative 1. And this is the most important thing that you can remember in this unit. Okay, I squared is negative 1, and we're going to keep coming back to that. Okay, so by using this, we can actually simplify what i's are. So just to kind of lead you into number 8 and 9, if we had x to the 4th and we raise it to the 3rd, remember there's parentheses between these. So when we take a power and raise it to a power, we multiply the exponents, and that makes that x to the 12th. Okay? So with that logic, then we can actually undo I to the 24th. So if we want to know what I to the 24th is, we can rewrite it so that it looks like, oops, sorry, not that. We can rewrite it so it looks like this. So the most important thing that we can remember is that I squared is negative 1. So that means that I want to rewrite everything to look like I squared. So I can say that I to the 24th is the same thing as I squared raised to the 12th, because 2 times 12 is 24. So those are identical. They mean the same thing. They look different, but they're both I to the 24th. Okay? The reason I want to write that is because I just defined up here that I squared is negative 1 raised to the 12th power. Okay? So if I took negative 1 and I raised it to the 12th power, imagine that I did negative 1 times negative 1 times negative 1, and I did this 12 times. I'm not going to do it all 12 times. 1, 2, 3, 4, 5, 6. And I continued. Well, what's going to happen is these two will pair to make a positive, these two will pair to make a positive, and these two will pair, and that'll continue to happen. So that means that if I take negative 1 and I raise it to an even power, I get a positive 1. So that means I to the 24th is the same as 1, which is a real number. Okay, let's say I have I to the 26th. So I start by saying I want it to be I squared because I know that I squared over here, I just said, was -1. Okay, sorry, let me cross it off. So I can take I squared and I can raise it to the 13th power because 2 times 13 is 26. So now these are identical. But by doing that, I can see that I squared is -1 to the 13th power. And if I take -1 and I raise it to the 13th power, I'm going to get -1 times -1 13 times. Everything's going to pair up and make negatives, except the very last one is going to be negative, which means that my answer is -1. So just like this, I'm going to get everything to pair up and make negatives, but I'm going to get 1 extra times -1 that makes the answer -1. Okay? So flip your sheet over, and let's do some more simplified. So we're just going to keep doing the same thing over and over again and see what kind of answers we get. So I to the 32nd is the same thing as I squared, and then 2 times 16 is 32. So I rewrite it like this so that I can say -1 to the 16th power. Well, -1 times itself 16 times is going to give me a +1. So I to the 32nd power is 1. Okay. Okay, next one. I to the 82nd power. So I start by saying I squared, because again, we know, I'm going to write over here. You should write this down. I squared equals -1. I want to write everything so it looks like I squared, because I know what that value is. So I can take 2 and I can raise it to the 41st power, and that way 2 times 41 is 82. So I squared is -1. If I take -1 and I raise it to the 41st power, I get a bunch of things that are going to cancel out with 1 extra -1 at the end. So I to the 82nd power is -1. Okay. Now let's look at something kind of close but a little different. So if I have I to the 7th, I start the same way. I squared. And notice that I don't want to raise it to the 3.5 power, even though 3.5 is 2. What I'm going to do is I'm going to raise it to the 3rd power. 2 times 3 is 6, with 1 more I left over. So I to the 2nd, raised to the 3rd, times another I. That's 2, that's 3, that's technically a 1 right there, and there's my 7 I's. Get rid of that one. Okay, so now I can simplify this. I squared is -1, raised to the 3rd, times I. Well, -1 times -1 times -1 is -1 times I, which means my answer is -I. Okay, so notice in all my other problems besides this one, the exponent was even, which is why I was either getting a 1 or a -1. So I had no i's left over, whereas in this one I had an odd number, so I had this I left over, and it ended up coming into my answer. Okay. Alright, this would be a really good place for you guys, since there's only a couple left. This would be a good place for you guys to pause and try on your own, and then see if you're kind of understanding what's going on. 13, 14, 15, you should be able to do on your own. Okay? So, assuming you paused and you tried these on your own, let's look at what those answers would be. So, start with I squared. I can't get to perfectly 401, but if I raise it to the 200th power, I get to 400, and then times I makes it 401. Okay, don't forget about that last I. You don't want to change this original problem. You just want to find a new way to write it. Okay, so I squared is -1 raised to the 200 times I. Okay, so if I take -1 and I raise it to the 200th power, that's even. So that means all the negatives are going to cancel out and just leave me with 1 times I, which is just I. Okay? Let's see how you did on the next one. So I to the 57th. That's the same as I squared. Notice I'm starting every problem the same. So that's the same thing as I squared. And I can raise this to something that gets me close to 57, but not exactly 57. So let's see. That would be to the 23rd. Nope, not 23rd. It's 46. 28th power. 2 times 28 is 56, so I have to multiply by one more I to make sure that that's I to the 57th power. So I squared is negative 1 raised to the 28th times I. So if I take negative 1 and I raise it to the 28th power, I get 1 times I. So my answer is just I. Okay, let's try it again. So I to the 102. You should have I squared. I want to raise it to the 51st power. 2 times 51 is 102. And I don't need any i's because there's nothing left over. 2 times 51 is 102. So notice we keep looking for half of this number. Okay? So I squared is negative 1 raised to the 51st power. So if I take negative 1 and I raise it to an odd power, everything's going to cancel, and I'm going to be left with a negative 1 at the end. Okay? Alright, now let's check the bottom. Alright, I want to simplify I to the 15th. So this would be a really good time to pause this and try this problem as well. Okay, so I to the 15th, let's check and see how you did. I squared, again, I start with the same thing. I raise it to the 7th power, but 2 times 7 is 14. I have to multiply by one more I to make 15. So I squared is negative 1. I raise it to the 7th power times I. Okay, negative 1 times negative 1, 7 times, since this is odd, is going to give you negative 1. Okay, and then I'm going to take this and I'm going to multiply by I, which means my answer, negative 1 times I, is negative I. Okay, so that means that I to the 15th power is negative I. Okay, let's try number 17. Actually, I'm going to skip 17. I'm going to do number 18. I'm going to come back to it. I to the 0 power. So if you remember this from either years past or Math 1, if you take any number and you raise it to the 0 power, you do not get 0, you get 1. So even if I took negative 7 and I raised it to the 0 power, I get 1. If I were to take 0.6 and raise it to the 0 power, notice I get 1. So no matter what I do, I get 1. Okay? There's actually an I button on here, so if I hit second and then the decimal, I can do I to the 0 power, and notice that it still gives me 1. Anything to the 0 power is 1. So I to the 0 is 1. Okay? Now, I just showed you that there's an I button on here. All those I problems are going to be done without calculators, so you can't use a calculator. So don't be trying to use that. And the calculator is weird. Sometimes it gives you answers, and sometimes it doesn't. Like if I did I to the 15th power, it gives me that, which obviously doesn't make sense, so don't use your calculator. Sometimes it works, sometimes it doesn't. However, it would be on a non-calc portion of a test anyways. Okay, next one. So if I want to simplify these radicals, so this is good review, I have negative 8, so I'm thinking about factors right now of 150, which would be 25 times 6 minus 2, and let's say you get to 96 and can't think of any perfect squares. Again, I would give you more reasonable numbers, but again, if you had a calculator, you could do 96 divided by and pick perfect squares. So I don't need to start at 100, 81 I don't need to start at, go down, 64 is too big, 7, I could try 49, notice that doesn't work, 96 divided by 6 squared, so 36, that doesn't work. 5 squared, I know 25 is not going to work. 4 squared, which is 16, and I can see that works. So I can do 16 times 6. Okay. And then, notice the numbers that come out. So the square root of 25 is 5, so I pull a 5 out. The square root of 16 is 4, so I pull a 4 out. So negative 8 times 5 is negative 40, square root of 6, minus 2 times 4 is 8, square root of 6. Now, imagine this was negative 40x minus 8x. You can combine those because they're like terms, and you'd have negative 48. Same thing goes for this problem. Okay, I'm going to get rid of that so I don't see it. This is saying I have negative 40 of these radical 6's minus 8 of these radical 6's. They're the same thing. So if I combine those, negative 40 minus 8 makes negative 48 radical 6's. Okay? If those were different radicals, like that was a 6 and that was a 5, then you could not do this. It would be like saying negative 40x minus 8y, and now they're not like terms. But since they're the exact same radicals, I can combine their coefficients. Okay? I believe that's it. So that's it. Your homework, you're gonna show your filled in notes to the sub, and the sub will give you the homework. This is what your homework looks like. So you're going to do some rewriting, so you can look back at the notes if you need to. And then after you do rewriting, you're going to do a bunch of simplifying. And again, the most important thing that you can remember is that I squared is negative 1, and you will write everything to look like I squared raised to a power. Okay, because you only have to memorize one thing then. Just know what I squared is. Okay, and then if you notice on the back, same thing, we got some simplifying of radicals, bunch of simplifying of i's. Why is that moving down? Simplifying of, simplifying of radicals, but a lot of practice with simplifying i's. Okay, tomorrow we're going to do a lot more with simplifying i's, and the problems become a lot more complicated. So make sure that you can simplify a single term where we take I and raise it to a power, because tomorrow we're going to have multiple terms. We're going to multiply, and then we're going to simplify. We're just going to do a lot more. Okay? But this is your homework. Show the notes filled into the sub, and he or she will give you the homework.